mentor at Techstar Space Accelerator, and sits at the critical intersection of federal R&D and frontier commercialization. Give it up for the panelists. Okay, so during registration, I think we all filled out a little question that we probably didn't spend too much time thinking about and maybe just threw an answer in, but the question was, what excites you most about space in 2025? And we got a ton of different responses: space interceptors, swarm systems, small modular reactors, mining on Mars, autonomous systems, hypersonic defense capabilities, and then literally every upcoming SpaceX launch. What struck us about were recurring themes around in-orbit manufacturing. So we're here today to talk about that. So the first question is to Ben. Ben, as you know, launch costs have dramatically collapsed. We're no longer asking whether we can reach orbit, but what we can build once we're there. So defense historically drives propulsion innovation. What does tactical mobility in orbit look like today? And then how is dual-use innovation redefining deterrence and resilience in space?
Okay, so multi-part question there.
Yep.
So, yeah, I think just to comment on the launch costs, it has been continuing to drop. That's what we've seen. That was really the use of Falcon 9. It is kind of plateaued, quite frankly, for the last couple of years, but it's going to probably continue to drop as we see more competition coming in. You know, Rocket Labs coming up with their larger rocket, Relativity Space, all need to price basically underneath SpaceX per kilogram to be able to be competitive. And then I think you'll see another jump, particularly from low Earth orbit, as you get to reuse second stage vehicles. So Starship comes online, there was a launch pad today. You know, Stoke Space can be coming online. I think as you get that second stage being reusable, we'll see probably another jump down, particularly for low Earth orbit. Geosynchronous, probably not really coming down anytime soon until you start to see more of the either high energy launchers, which, you know, they're not really making any upgrades to Falcon Heavy. ULA is kind of making incremental upgrades with Vulcan, but I think really the OTV market will start to grow a bit more there, drop the costs down as it continues expanding out. What was that next question?
Yeah, how does dual use play a role in the government collaboration? Because since government and the DoD have been primary accelerators of the launch capability, as we now see commercial capability come online, does dual use still play a role with the defense market?
Yeah, absolutely. I mean, I think I can talk more personal experience a little bit on orbital operations. We're developing a high thrust cryogenic vehicle out in orbit. We see a ton of traction on the commercial side, particularly for reconnaissance type of vehicles, fast transfer orbits, but also for space-based interceptors. The exact same technology could be applied on the commercial side for, again, reaching geosynchronous or lunar orbits, translunar injection, whatever it is. And they are still pushing for dual use cases. So I think you know, having an understanding of how this technology can be applied in both the commercial and defense markets is a good kind of business case. I will say there's been maybe more and more, I wouldn't say tension, but I've seen through some of the workshops and communications with SpaceWorks and others, you know, as we go into a more contested zone, you might need to start having technologies that are not fully dual use. And I think they are starting to look a little bit towards it. And there's only so much that can be dual use before you go into a conflict with an adversary. And then, you know, there are going to be specialized technologies there. And if they want to continue working with startups, are you going to have startups that are just doing like singular use type of technologies? So I think they still want to see the dual use, but I could see an argument being made towards more specialized use for sure.
Yeah. Yuke. Can you talk about launch and risk and how you see the insurance market around launch and risk around launch change? And then what is the future of that as we see much more launch capacity open up in the next few years? I've seen probably in every other pitch deck a schematic of Starship and how many of the things can fit inside of it. So what does that look like?
Yeah, so that's a great question. So there's a distinction between risk for launch and risk for in-orbit operations, right? It's a completely different risk profile. So with launches, I'm gonna get a little bit technical here. So with launches, obviously the risk attaches more primarily to the launch vehicle than any of the individual payloads, given the sort of cross-waiver liability system that we currently have with any launch vehicle. it's almost immaterial what the individual payload risk or what risk the individual payload poses to the overall launch vehicle and the success of launch. So right now we have a very sort of standardized model for different launch vehicles that are on the market. Falcon 9 is, and don't quote me on this because this is not legally binding insurance advice, but the current prevailing market rate for Falcon 9 is between 3 to 3.5%. Now, percentage of what, you may ask? Basically, it's whatever your insured value is, right? So if I use any percentages, Falcon 9 is about 3 to 3.5. Electron is, I want to say 8 to 9 points now. Vulcan is about 12 to 13 points. And pretty much nothing else is insurable. That's not true. PSLV, I think, is also at about 7 to 8 points. I think. I haven't checked super recently. Now, in terms of trends, the reason why, so Falcon 9 is a really good example to use to describe this trend. Basically, launch insurance is overpriced. The reason why is because the insurance industry as a whole is trying to compensate for historical losses that it suffered over the last 10 years. 2018, 2019, and 2023 were really, really bad years for the insurance industry because we suffered massive losses relative to revenue. Revenue has remained stable for about the last 10 or so years, whereas in certain years, losses just explode for whatever reason. Explode literally and figuratively for whatever reason. And so that's why Falcon 9, despite having a historical loss rate of sub 0.4%, is priced at 3 to 3.5. Right? It's clearly overpriced, but the insurance market is basically trying to compensate for that. So those are the interesting trends on the launch side. Now, on the in-orbit side, well, the historical trend and the current trend is it's expensive. It's really expensive. It's not really going to abate. And honestly, an increase in launch capacity isn't actually going to change the rates of launch that much because it's a completely different risk profile, right? Starship, when it does fly commercial payloads for the first time, will probably be fairly expensive, and over time it will get cheaper. That's how launches get. The insurance for launches get cheaper over time. It's just history of performance, right? Just like anything else. In the same vein, in-orbit insurance is going to remain expensive until you have sort of mass-produced satellites on the scale of, for example, Starlink. Now, fun fact, SpaceX self-insures everything that it sends up. It self-insures all its rockets. It also self-insures every single Starlink satellite. And arguably, it actually doesn't have to insure any of its spacecraft because it's not designed. It's designed to be triple. Anyway, yeah, those are some broad trends.
Yeah, that's great. Can you talk a little bit as we start to move things around in space much more? And it's not necessarily launch, but we have these high thrust vehicles moving something from LEO to GEO or from one manufacturing facility to the next. How is that going to happen?
Not to sound like a bit of a cop-out, but it's unclear how things are going to change. Mainly because the way that insurance is underwritten in space for in-space operations today, it does take into, okay, so we bucket risk into two broad categories, right? Intrinsic versus extrinsic risk. Intrinsic risk being how the spacecraft was built, designed, tested, whatever. And then extrinsic risk being, what the odds it's going to collide into something or get hit by debris or whatever. Extrinsic risk actually is not a very important part of the calculus today. Now that's a bit of a weird little accident of history. If you imagine, so I'm going to bore all of you with a history lesson. The very first space insurance policy ever underwritten by Lloyd's of London was in 1965. It was Intelsat 1. It was 4 years before we landed on the moon. So it's got a very, very sort of long heritage as a product category. Now, historically, only GEOs have been eligible for insurance. Now, if you think about sort of the environmental profile of a satellite in GEO, space debris isn't really a problem. Extrinsic risk isn't really a problem. The most that you really have to worry about is space weather. But space weather, well, I'm not going to say it's easily modelable and predictable, but it's a lot more predictable than space debris, right? Because you have something to observe. Now, because of that, the historical underwriting models that have been used for in-space risk take that into account, and they don't take into account what is the likelihood of something smashing into you, right? Now, you fast forward in time to the last decade of in-space operations, where all of a sudden, we're overemphasizing, we're not over. There's a greater emphasis on LEO, and there's a greater emphasis on things being in this sort of very dynamic, highly kinetic environment. we just don't know how to price that risk yet. And ultimately, a big part of that comes down to one, data. We don't have sufficiently advanced tracking capabilities, right? We're not able to actually understand where everything is in orbit sufficiently well, with sufficiently high fidelity to actually have a really strong probabilistic model. But also the other aspect is, there's really no reason to do any of that because we don't insure a whole lot of things in LEO. Most things in LEO are functionally uninsurable as of today because of a variety of different reasons. And all this comes down to the intrinsic risk. The biggest reason why anything is uninsurable is due to intrinsic risk. So to answer your question, I really don't know what the impact of things moving around in space will be because today, at least insofar as its impact on insurance, because today its impact on insurance is minimal. Now over time, or as more things get insured, that may change, right? But if you think about it in terms of like when cars were first introduced to the roads, you try to get car insurance, you're probably more concerned about the car blowing up underneath you than getting hit by another car because there just weren't that many cars on the road, right? So that's
living in space. What do you think is the first commercially viable product we'll see made in orbit? That's the first question. And then the second is, what does it take to scale from a demo to a factory?
That's a great question. So, there's been a lot of interest recently on the biotech side from some monoclonal antibodies, the anti-cancer drug and so on, and formulating that in space. I think that's really exciting, but there's actually some regulatory challenges around bringing that to market. We have to get the government on side with it. So I actually think the first one that we'll see will actually be sort of around the fiber optic and semiconductor side. And the reasoning is that while those have very specific needs in terms of production facilities, that's what we're focused on, they don't need to have the same type of government regulatory approval. And once you've got them working, you can just sell them on the open market and say, hey, look, we've got the performance benefit, we've got the yield benefit, and you're away laughing. You don't have these extra restrictions imposed upon you from government.
Yeah. And then, okay, how do you scale that from a demo to a factory? What's required? What do you think is the next generation of scaling something from we're on the ground to, okay, we're building in space at this point?
Sure, so a lot of the demos that are going on nowadays are with free flyers. So that is where you put your entire factory and the product inside a re-entry capsule, you launch it, you make a product and you bring it back to Earth. And you can pull it out and say, hey, look, we've got our product, it's great, it's got this improved performance, improved yield, and so on. The challenge is when you do that is that you're shipping all of your equipment up into space and you bring all the equipment back down. So the actual amount of product you're getting is single-digit percentages. So what really is required to move it to scale is having a place in orbit where you can leave that equipment and you just bring product up and the manufactured product comes back down. And that's what really changes the economics around the logistics of manufacturing. The other one, of course, is just getting the actual end users on side, the large semiconductor manufacturing companies. And someone told me the other day that these guys don't get out of bed for less than 1 million units. So you need to make sure that they have confidence that the overall supply chain is there. And the great thing is that once you've got the circuit completed, once you've got this first one going, you just repeat that over and over and over, and suddenly that quantity is now more and more used to, and that's great because now the market's there as well, because it's a huge market just by default.
Ian,
that we are going back to the moon, and that was town hall a couple of weeks ago that very clearly said, if you're not working on lunar to Mars, then basically just don't come to work. So that's the message from Washington, D.C. The good news is the associate administrator actually has a lot of experience in commercial space. So I think that what I work on and where I'm interested in is this merger and where we can start to transition things past NASA into commercial space and the growth of the startup ecosystem. I've been in it for 6-7 years now. Super exciting. I don't think we have an official position. I think there's a lot of interest in really stimulating that economy and moving it forward. There's obviously non-operational government right now in Washington, D.C., so it's a little hard to know exactly what's going to happen, but if you look at what our colleagues in the Space Force and the DoD are doing, there's definitely clear messaging that, new space is the way to go versus big defense primes, right? That's a clear message. So I'm hopeful that that's going to translate over to NASA, because a lot of us at NASA have been looking at that for a long time, thinking about how can we stimulate this economy, even though it hasn't come, we call it the ninth floor, that's where the administrator sits at NASA headquarters. It hasn't come down from the ninth floor in a clear message, but what we're hearing is lunar. I mean, we all know to get to lunar, what do you need? Well, you need autonomy, you need robotics, you need in-space manufacturing. Those tools that we are all tracking from the last number of years are mandatory for us to get to the lunar surface. I mean, we're not going to do it with astronauts in buggies like we did in the 60s. I mean, as cool as that sounds, that was pretty challenging, and there was a lot of real risk. We talk about risk. I mean, lunar ops, there's a real risk of lunar operations. And so as we're trying to put a nuclear power plant or LTV, the lunar terrain vehicle, on the moon, that's the message that we're getting. So, okay, work with CLIPS, Commercial Lunar Payload Systems, which is a big program at NASA that's funded Lunar Outpost, Intuitive Machines, Firefly, all the programs that we're seeing a lot of successes in right now. That's through CLIPS programs, so we should all get behind that and make that work, because the first couple of years of that was a little rough, but it's getting better, and I think there's a lot of interest from NASA at the boots on the ground level to acknowledge the newest space economy and move it forward in ways that this administration started a lot of this, and I think we're picking up. I don't think it really ever dropped off in between the two administrations, but it's definitely starting to ramp up from what we see on the DoD side.
So you,
Okay, sorry, few people in the back, they are having difficulties hearing. So you guys
okay,
can
we'll speak closer to the microphones.
Definitely seeing that on the commercial perspective, right? That not only on the NASA side of things, but on the DoD side of things as well. A move away from the primes is not just talk. Like they are very strongly looking for innovative, kind of newer companies to take this tech and actually run with it. I've seen that on the DoD side and on the NASA side. And then, you know, maybe I call out more for companies that are getting started. Like there are a lot of test facilities and resources within NASA and other bases as well, AFRL, that are looking to engage with startups. Either, you know, we're doing a Space Act agreement, but there's like Eclipse programs. There's all these kind of various programs with thermal vacuum chambers and expertise to kind of build on there, and they are actively pushing to find startups. So absolutely should be reaching out to kind of the local centers and figuring out, you know, where there's synergy in the technologies. But yeah, just wanted to affirm that on the commercial side.
Absolutely, and I think here in Southern California, we need a catalyst type campus that's really supporting that, because there's a lot of activity going on. There's a lot of big players, you know, Relativity in Long Beach, Rocket Lab, there's, you know, the whole Space Beach and everything that's going on down there. But really bringing together the community, not just in informal networking like this, but aligning teams, right? I mean, JPL's been in space, well, we had the first US space satellite since the 1950s. We've never done it on our own. There's always been Lockheed Martin there. There's always been Hughes Aerospace, Northrop Grumman. Everybody partners with space. And this idea that one company's going to do it by themselves, okay. Well, if you're Elon Musk and you can write checks that big and self-insure yourself and control the cost of the rocket, you know, that's almost effectively acting as a government in its own, and as SpaceX in themselves, and then subsidizing your satellite network that you're launching. You know, there's a lot of like kind of interesting plays and how SpaceX is almost acting like what a particularly like government space agency used to act like. And I mean, that's something that would be interesting to watch, I would say, if Starship launches. But how can we bring the experience of the US space program and stimulate the three companies that are sitting here in a more, not necessarily like controlled, but just how we build on that experience. And yes, I think you're right. I think we're gonna see a shift at the NASA level to say, yes, bring in charter, bring in Relativity, and sort of new space economy into the old space business, especially at the federal level, because that's really what we're supposed to be doing.
So I'd like to go down the line and have each of you answer this question. So starting with you, we're talking about transition. It's sometimes can be a scary word for a lot of the companies here in this room, even larger companies that want to transition a technology, capability, or an idea into the DoD or into the federal marketplace. So specific to each of your businesses, what does it look like? What would be the key that would unlock your transition into working with the DoD?
Well, I think the first step would probably be the civil reauthorization bill going through. That would help. Yeah, I think ultimately it's well, I think one, it's a numbers game, and two, it all depends on the availability of funding, where the funding is flowing, right? So funding for, well, depending on which specific stage your company is at, for us, we're still trying to, we've never historically done a whole lot of work with the DoD. That's never been a major focus of us. Federal contracting has never been a major focus of our company. We're primarily commercial first, and so because of that, we've only recently started paying attention to sort of federal programs. And so for us, we're sort of in this weird space now where we're looking to see what the next sort of pot of civil funding is going to be. As I'm sure many people in this room know, the last pot of civil funding was primarily dedicated to TAC-5, Strat-5 awards, which is great for those guys who got the TAC-5s and Strat-5s. Not so great if you're trying to get phase 1 to convert to a phase 2. So I think that'd be the first thing, sort of catching the funding cycle where it is, and the rest of it is just provide a valuable piece of technology to a program office or a customer that actually needs it, and then honestly just keep emailing them. So yeah, that's those are things that probably matter the most for us. The funding, the right timing, the funding cycle.
Yeah, and so for us, we've spoken to different people from the Space Force who are really excited by having test beds in space where they can go and test their technology, run different proximity operations, all these things that are required for this the type of space economy we're talking about. But those particular ones individually may not be directly plugged into the exact pot of money that is required to help it. So just smoothing out some of the disconnect between these groups who really want it and the groups who do supply the funding, and keeping some alignment there.
Yeah, not saying anything that I don't think hasn't been said. I mean, particularly like phase 2 SBIR, right, kind of opens up the rest of the world for you for TAC-5, Strat-5, whatever the next phasing looks like. I don't know what things would look like without the SBIR program, and whether honestly, even transitioning from kind of an engineering role to some of the business development and government contracts, like understanding, what avenues are there for OTAs or specific topics, and building that out. And if the kind of standard phase 2 program went away, what that would look like, I think is going to be really pretty challenging. And building, continue emailing, but building those relationships, understanding, navigating kind of the map of who owns what is a big challenge all on its own. But once you kind of find the right group and get that communication going, I think it kind of opens up, when future proposals come around, right? So for companies looking to get into that world, like it's a challenge just to understand kind of who owns what, and people transitioning from one department to another. And so take the effort to kind of understand like who your customer is within the DoD, and it usually starts with kind of space work events or open door, and then you kind of keep navigating through that, and it's a long process, but if a government contract is key to the business, then it's worthwhile doing.
So Ian,
I want to tap. So I'm an Earth and atmospheric scientist. I've been studying for over a quarter century remote sensing, which is really arguably next to SATCOM is the real first go-to-market of satellite technology. I would argue. I don't know if anybody disagrees with me on that. We could talk afterwards, maybe over a beer. But there's a continuum. It never ended. So if you look at GPS and remote sensing, which are completely developed by the DoD for tactical purposes. Satellite remote sensing for spying on people, GPS for putting ballistic missiles into Russia, maybe China. But that's coming back. And so if you look last week, the Nuance Space up in the Bay Area got a huge SBI, phase 3 SBIR for commercial development of wildfire satellites. Like all that technology we know exists inside the DoD. Here we have the DoD Space Works funding them, I think it was $70 million, approximately that. That's a big win for them. And they were already funded by Google and Moore Foundation, so the Betty and Gordon Moore Foundation, to build these satellites. And then they just got a plus up after they got philanthropic money to build 3 more of these satellites for the DoD. I mean, I find that fascinating that it's really a revolving door of tech coming in and out rather than a one-way street.
Yeah, so just one follow-up question on that. What do you think of Innovate? What do you think is the future of the Sitter program? Because I know personally working with NASA is different than working with any other organization, because NASA has built enabling infrastructure that companies just aren't building. They're not building TVAC chambers to be the size to test some equipment that is now being built out there. And I just imagine as you have larger and larger manufacturing facilities that need to go in orbit, you need the enabling factor that comes only from an organization like NASA. So yeah, what do you think of Innovate?
I think the SBIR program has been successful. It's not tooled to venture, and it's not tooled to philanthropic organizations. And a lot of the money, the non-dilutive money, are coming from, well, venture's not dilutive. But a lot of philanthropic money that we're seeing coming with big checks that are writing it are coming out. So I think that the SBIR program, I think what SpaceWorks and AFWorks has done, it's revolutionized it. DoD, what DIU's doing. I mean, the DoD's pushed the limits because I think they have other abilities to contract in different ways because they're tactically supporting the warfighter. And if you look at those programs, that's what they're focused on. DOE, NSF, NASA, NOAA, we don't have those tools because we're focused on a mission-specific topic. So if we could retool the SBIR program to where we are right now with the reality of venture needing to monetize or value an SBIR, that's not there right now. So we need to change the SBIR program. Is Innovate the right answer? I haven't read the bill. I'm not going to sit here and say, oh yes, because I just haven't. There's a lot of other bills that, there's a lot going on right now. And so I think I have been for retooling the SBIR program for the other agencies. Now, that kind of concept that we keep getting back to on tests or subject matter experts and how do we leverage that, you know, like what aerospace corporations did with Space Force with TRL boot camp over in El Segundo, I think it's a real win. It's been very successful. It's been very mission specific, mission focused. And so I think we want to think about if we're going into the NASA facilities, when we go into the NASA facilities with startups, what is the mission we're trying to go to? Are we just trying to go to the moon? Are we trying to go to Mars? I mean, I think we want to get clear as a community on what is the topics that we need those test facilities. Because as somebody that has to write the justification to do that, and I'm literally working on it right now, it's not that easy to just say, well, I know Yuk from, we were Techstars together, we've been buddies for years, you know, I'm gonna bring him in. That doesn't really make it through legal. But if we're talking about risk posture and insurance in space and we have a clear mission objective, I just think as a community, we want to get clear on what is the objective of coming into the test facilities. And I don't think it's SBIRs don't work. I think it's, well, if we do this test and we bring K2 spacecraft into, I was literally in a clean room today that's 10 times the size of this room. And we can bring those in, and NASA's got it, Goddard's got it. We want to bring those in. We want to use those facilities, because right now the way that federal funding is drying up, we'll lose the Apollo era program space resources that we have. And we need to come together and think about this pretty quickly and pretty tactically to really build to build the economy, build the ecosystem, continue building it, and C, to save these resources that are global. I mean, there's, a global legacy that will allow us to be an interplanetary species.
Thank you. Yeah, by my estimation, we'll either find out tomorrow before everyone gets paid, or it'll be a month from now. But hopefully sooner rather than later, we'll get out of this shutdown. I do want to open it up for some Q&A. I think we have a microphone out there, or you'll use mine, and I will walk around. So yeah, if you have a question for a specific panelist, that would be helpful. If not, you can direct to the whole panel, and we'll get some good conversation. Any questions? Oh, also, please keep it short.
How's it going? This one's for you, NASA. Excuse me. You mentioned a lot about remote sensing. Pardon my voice here. You mentioned a lot about remote sensing. A lot of the orbits seem to be going down. So you have geosatellites, LEO satellites, and it seems like VLEO is emerging as a new orbital regime. There's a few companies in the space who have tried to capitalize on that. What do you see as an optimal use case, whether on the government side or dual use side, that could really optimize that new regime?
That is a totally good question, and I think it's interesting. Last week, Albedo canceled their remote sensing market, and I forget, I've talked to Topher Warren over there to figure out exactly. I mean, it makes sense that they're focusing on spacecraft bus, but I was a little surprised when they pulled out that remote sensing product line. And I mean, and there was, it was posting about layoffs, and I mean, obviously they had a big decision that they had to make. So that, right now, that question's totally fair, and it's a little hard to figure out. I mean, there's some questions about like upper atmospheric sampling, but I don't see that as really a market share there. Like, I don't see an MVP in terms of sampling the upper atmosphere. And so then you think, okay, I guess once LEO gets congested, you can put SATCOM up there. It's going to reduce your latency. You can't go out to GEO. It takes too long to transmit the data out there. I haven't figured that out, and I've really tried to wrap my head around that just to see what the MVP is for it. But the other question is a lot of what we're talking about in terms of autonomy on the orbit refueling. I mean, that's a pretty costly operational zone. And so I haven't seen how they're, once Daniel Faber gets his gas station in space, he'll be able to refuel them all. But I mean, and seriously, I think that's part of their play. So it's just a complicated, I actually am more excited about GEO right now, because I think LEO's getting taken up. But Yug's I'm not gonna pass it right here. Thank you.
Yeah, I actually have a lot of opinions of VLEO because I used to work at a company that was manufacturing VLEO buses that unfortunately died because I like to say that we were ahead of our time. It was like 5 years ago. But great question. There's a ton of different operational benefits to operating VLEO. Now, the reason why you want a dedicated bus company for VLO is that VLO presents a ton of interesting operational challenges. So obviously there's much higher atmospheric drag, but also the higher concentration of atomic oxygen actually creates incredibly challenging materials questions. It's incredibly erosive for optics. You need to hold in your optics in order to not get completely just like messed up by the environment. But there's a lot of interesting operational benefits. One, it's much harder to shoot down satellites in VLEO, right? So from a military tactical satellite applications perspective, there's immense benefit there. I'm forgetting my numbers, but if I remember correctly, the signal to noise ratio benefit is whatever the distance is in terms of the ratio to the power of 3. I think reduction power draw is that same ratio, but to the power of 2. Obviously, you get much better resolution without increasing the amount of the data packet. It's going to be the same size. Now you get a much smaller swath width because you're obviously a lot physically closer to the target. But if you're only using it for specific tactical applications, like let's say you really want to pay attention to like 1 square mile, it doesn't matter, right? So I think that there's a lot of benefits to VLEO, and I would die on this hill.
Yeah, I'll get you right after this. Thanks for the presentation, really good guys. My question is to Lee and Ian, and I think that some of you already touched on this, but I'm curious to know how the directive of Lunar First is going to affect
the manufacturing efforts in orbit, specifically with the Lunar Gateway, what kind of technologies do you see as more promising now that we have this shift into the priorities?
Sure, that's a great question. So there's a couple. So, with Gateway, you need sort of some robotic aspects to it ideally, take advantage of it. It's not being manned the whole time. But one thing that we've found actually is, we got an award a while ago for putting a centrifuge on our platform to do simulated lunar gravity, because there's a lot of things that happen, just in terms of dust settling, in terms of regolith, even the life support and fluid flow changes and it's different in lunar gravity, and you can't do it for long enough on Earth to really have it make sense. And so we see this as a small niche market that actually helps the system platform business sort of as sort of a stepping stone for manufacturing. So we actually see this enabling, it's not sort of a separate thing. So that's sort of an interesting niche from our perspective. I'm not sure if Ian, you have a different one.
Slightly different, but basically the same approach that I think we're going to find as they're trying to go to the moon. It's a really hard operational environment, and it's going to stimulate the in-orbit manufacturing, because maybe you're getting materials off the moon, but you're going to get those up onto space stations and then utilize those space stations. I didn't think it's going to stimulate the space station market rather than cause conflict for it. Because the moon's hard. I mean, I think anybody that's not acknowledging that. I mean, the lunar dust is really no joking matter. If you dig back into what happened during Schleuniger and Apollo, I worked on a program called Cadre. We built 3 autonomous robots for the moon, and I had the luxury of, for 3 months, of doing a deep dive on exactly what happened during Apollo. And basically, all the spacesuits were at the point of failure when the astronauts came in, and they were having huge respiratory problems because they weren't cleaning up the spacecraft on the LTV when they were returning. I mean, it was basically everything was at the point of failure. And in some ways, I joke the reason we're going back to the moon is because almost everybody's dead that went there the first time. But
Okay, we'll get the last question here.
I actually have 2 questions, one for Benjamin and another one for you. And they are related to in-orbit propulsion, right? My question for Benjamin is, do you project that these very high trust engines are going to be the ones dominating the market, not only on the defense sector, but also on the commercial space? Do you project that low trust, variable ESP, in-orbit refueling, right? Where do you see that going? Like high trust engines relying a lot, spending a lot of gas, propellant, I guess?
Yeah, I think it depends on the problem you're trying to solve, right? So if your goal is to station keep and be able to have enough maneuverability to avoid, orbital debris or whatever it is, I think that you can go, you're usually trading efficiency for thrust, right? And so there's always going to be a market for electric propulsion in particular to be able to station keep and do kind of smaller, lower thrust maneuvers with super high efficiency, 2000 and above ISP, right? I think you're starting to see a little bit more one kind of contested domain, but then also just a size and payload that we want to get out to geo and lunar markets and transport, and that's where you start to see a want to go to a higher thrust, and the push is to bring that higher thrust to a higher efficiency, right? How do we go from 220 seconds of ISP to above 300 to above 400 to go to thermonuclear where it's high thrust and then 900 plus seconds of ISP, right? But it's a different use case and a different tool in your toolbox for what you're trying to solve, right? It's a huge domain with different problem sets. So there's always going to be a use case for both. It just really comes down to what you're trying to do.
A follow-up, and I got to you. How interesting would you think that will be to have variable ISP in orbit? That you have an engine that you can go from those 200 seconds to 1200 seconds in orbit?
Yeah, I mean, there's definitely bi-propulsion or a dual use type of propulsion, or you have electric and a high thrust use case on board. And again, it kind of depends. There's kind of different regimes where maybe orbital reconnaissance on a DoD side could use both a lower thrust engine and kind of a higher-ish thrust, maybe 15 to 50 pounds of thrust for quick short burst maneuvers. What we're doing is 15,000 pounds of thrust trying to go out to higher orbits and do rapid orbit chains and getting out to the moon. That's just a different tool set altogether. But yeah, I totally agree. There's definitely use cases across the board on where different tools will make sense. Will there be one that rules them all? I think the answer is no. That's my personal take. But
Thank you. For you? Yes. So my question is regarding Vileo that you mentioned. Besides the optical and that single oxygen they're messing around, do you think that like one of the issues with Vileo is that the return of investment of this spacecraft is low because the station keeping and propulsion technologies also struggle with that oxygen, molecular oxygen there, or mostly electric propulsion, right, Hall thrusters?
I don't know. So I don't know if it's necessarily a bad return on investment because I haven't done the numbers, right? It's entirely dependent on the specific technology. What I can say is that the company I used to work at, we were trying to develop a new type of station keeping device, and that's what we thought would make VLU economical. Ultimately, I think it really has to do with one swap seat, right? So if you one of the sort of things that we kept running up against was the idea of you want to last longer in sort of the theater of operations, which means you need more propellant, which means that you have you have more mass, which means that you need more propellant, and it becomes sort of an endless cycle. And that's what inherently made it uneconomical, in addition to all the material adaptations that you would need. I don't know, man. I mean, there's many reasons why that company isn't around anymore. Maybe economics of it had to do with it. Not really very sure. But what I can say is that from my current perspective, given what we underwrite at Charter and what we help insurance companies to underwrite, VLEO is currently challenging to underwrite, right? So viewing it from a different perspective on your original question of return on investment, I think that the insurance market is fantastically efficient at pricing what is or is not a valuable asset. The fact that VLEO is currently very difficult to price from the insurance perspective, I think may indicate that your question has some validity to it, that maybe the investment isn't quite there yet. Maybe after a while, after we prove it out, or the technology is a lot more mature, potentially, but at this point, I just don't know.
We actually have time for another question. If there's one. Anybody?
This one's for the panel, not to stir the room here, but why hasn't SLS been canceled?
I ask myself the same question every day. Aerojet Rocketdyne gets awarded 10% of NASA's budget. If you look at the size of Aerojet Rocketdyne's contract for, was it RS-25, right? It's $2.1 billion. Seriously, it's 10% of NASA's budget for one contractor, for one thing that only kind of flies. I don't know, man.
I said I don't want to stir the room.
I mean, they're talking about moving the space shuttle from the Smithsonian to Texas. I think that answers the question. I mean, the like craziness of that. Like, you have a perfectly good orbiter sitting in the controlled environment in Virginia, and they want to dismantle a historic relic, and they want to move it to Texas. That's kind of exactly why SLS is still there. I mean, Brian's team came out, what was that, 2 weeks ago, and it was very clear, though, that dependent on SpaceX is not beneficial either, right? So we want to be clear about having multiple sources of launch, and I think what Rocket Lab's done is awesome. I think the new leadership at Relativity is awesome. I think there's a lot of shakeup going on because there's a desire to not just be dependent on SLS, not to be dependent on a Starship. And we want to have competition inside the space industry, and I think we are. So, I mean, it's politics, that's what it is.
Anyone else want to stir? All right. Thank you all. Let's give a round of applause to our